Hello there, you're welcome to this page. Today we'll be talking about work, energy, and power. But in the previous video, we talked about work. So if you missed that video, you can click on the link in the description. So I prefer you watch that one before you watch this to gain more insights on what you're about to do. Okay, so let's take energy. So energy is basically the capacity for doing work. So before you do any work, you need energy to do it. So energy is basically the capacity or the ability to do work, and it is measured in joules. We have forms of energy. We have light energy, solar energy, heat energy, chemical energy, mechanical energy. But mechanical energy is a combination of kinetic energy and potential energy. So please know this. We have so many types of energy. So so many forms of energy. You can research on them, but I just listed four. So we also have a principle, which is the principle of conservation of energy, which states that energy can neither be created nor destroyed, but can be transformed from one form to another. So that means energy can be transformed from chemical energy to heat energy, can be transformed from heat to light, from solar to heat, from heat to mechanical, depending on the process in which the body is going through. I hope you understand what I'm trying to make. Okay, so let's continue. Potential energy. So potential energy, it is the energy possessed by a body due to its position or the position or its height above the ground. So put in mind that potential energy is always active when there is a height. So there should be a height before you can say there is potential energy. So let me illustrate what I'm saying. So let's say we have this floor here. No, sorry, I can draw something better than that. So let's say we have a floor here. That's better. And we have a mango tree. Let's say this is a mango tree. And this is the mango. So as you can see, there is a distance from this mango to the ground. From this mango to this floor, there is a distance which we call the height. So from here to here is the height. So here the energy possessed by it is potential energy, because there is a height from this mango to the ground. Please do get what I'm saying. So this distance is what we call what? The height, represented by h. So there should be a height. And if you remember in the last video, I talked about work done, and I was like, work is done when a force moves a body through a distance in direction of the force. So here that means there is distance. So we say work is done when there is distance and the force moves it in the direction of the force. So here, let's say the mango unplugs. So the force, let's say the force is moving in this direction. So if it's coming down, the mango too will move in that direction. So that means work will be done. So that means the work done for this is that force, which is F, multiplied by the distance or the vertical distance from that point, which is the h. So you can say work done equals force times what? Our h. So since it's acting with the potential energy, you can see that potential energy is equal to work done. Please do get what I'm saying, because it's in a height, and the work done to deals with distance, which the height to is a vertical distance. So you can see that potential energy is equal to work done. Good. So that means our potential energy is going to be force times our distance, which is h. But you know that force is equal to mass times what? Acceleration due to gravity, which is g. So our formula will now be m times j times h, which is mass times what? Gravity times height. So I hope you understand this section. Don't Please forgive me for my enjoying. Okay, so let's move on to kinetic energy. It is the energy possessed by a body due to its motion or velocity. So we say that a body possesses kinetic energy when it has what? A velocity or it's in motion. That's when you say it possesses a kinetic energy. So as in this form too, as you can see, let's say a car is moving, it will move through a distance, and the force which is moving through to it's in the same direction. So here too, we can say work is done. You can say work is done. That means our work done can be equal to what? Our kinetic energy, because they are all aligning in the same direction. Please do get what I'm saying, because for the kinetic energy there is a motion, and in that motion too there is a distance, and that distance too is in the direction of the force. Same applies to the work done. So that means kinetic energy, there is a work done, so they are equal. So you can say that work done is equal to mass times what? Acceleration times our distance. Good. But here we don't know our distance, which is s, but from maybe we talk about that in another video. From the equation of uniform acceleration motion, v squared is equal to u squared plus 2as. There are three equations, there are three, but there is one of them. So v, which means what? Our final velocity, u, which is our initial velocity, a, which is what? Our acceleration, and s, which means our distance. So we have this. So this is a formula. So maybe in one of the videos you'll be talking about this, so make sure you don't miss a video. So if you make s the subject from this, that means you are going to bring u squared to this place, u squared to this place. So that means, or you can subtract u squared from both sides. It's the same, either you cross it to here and it becomes negative u squared, or you subtract u squared from both sides. So it's going to be, if you do that, it's going to be v squared minus u squared. Good. But here we want our s to stand alone, so it's going to be equal to 2as. Good. We want s to stand alone, so we can divide both sides by 2a, both sides by 2a. The 2 will cancel the 2a, and we get s to be this. So that's how we got this formula. So I hope you are true with that. But how we got this, I'm going to explain it on the next slide, but I hope you understand how I did this. All right, so let's move on to the next one. So let's solve that one. So as you can see, we said our s was v squared minus u squared over 2as. Good. And we said that our kinetic energy, which is equal to work done, is equal to what? Our mass times, our mass times our acceleration multiplied by what? Our distance. But here we know our distance to be what? V squared minus u squared over 2a. Good. If we check this, we can do some calculations or elimination. This can cancel this. Good. So it's going to be left with m multiplied by v squared minus u squared. V squared minus u squared is also the same as change in velocity, because there is change in velocity squared, because there is a change from the final velocity to the initial, from the initial to the final. So here there is a change in velocity from the initial to final, but they are squared. So this is the same as velocity. So here we can say that ke is equal to m multiplied by v squared minus u squared all over 2. You have something like this. It's the same as velocity, but here there is a change in we only use this formula. This can also be written as half. You only use this formula when you are given two velocities, when there is a change in velocity in the question. So maybe we'll take an example in that during this video, but when there is only one velocity, we use the formula. Since it's the same as the v squared minus u squared is the same as change in velocity, we use the formula m v squared. It can be over 2, or you can do it half, but mostly we do it half. Anyhow you want it. That's how we got this formula, which is kinetic energy is equal to half mv squared. Half mv squared. This is half times mass times velocity squared. So this is how we got this formula. So let's take an example for you to understand what I've said so far. So a mango fruit, let's read it together. A mango fruit of mass 50 kilograms hangs on a tree 50 meters above the ground. What type of energy is possessed by the mango? And determine the amount of energy. We should take gravity to be 9.81 meters per second square. Okay, so we have this question. If you think you've understood what I've said so far, you can pause the video and try and do it. If not, let's solve it together. Okay, so we have our, as I said, when there is a height, the energy possessed by it is what? Potential energy. So here we were given a height of what? 50 meters above the ground. So that means there is a height. Please do you get me? So the energy possessed by it is what? Potential energy. So you should keep this in your mind. And we are given, since it's potential energy, and you should find that amount of energy. We are given, potential energy is mass times gravity times height. We have our mass to be 50, our gravity to be 9.81, and the gravity, sometimes in some questions you see it should be 10, but I think the actual value is 9.81 something, but we are using 9.81 for this video. So 50, our mass is 50 kilograms, our height is 50 meters, and our gravity is, so their product will just give you what? Our potential energy, because this mgh. So if you have their product, you are going to get this answer, 24525 joules. So please, if you want to write the joules in words, use a small letter, but if you are writing it in like this is the symbol, choose a capital, or else I think you'll be penalized for that. All right, so let's move on to the next question. All right, a motorbike of mass 1600 kilograms increases its speed from 16 meters per second to 40 meters per second. Find the change in kinetic energy. So this example of the question I was talking about, when you have to use that formula. So here, let's solve it. If you think you don't understand, we are solving together, but if you understand, you can pause the video and solve it before you continue. Okay, so kinetic energy is equal to half mv squared, but here you see, as I said earlier, we have a change. When there is a change in what? The velocities, it's no longer v squared, but it's the change, which is what? V squared minus u squared. There is a change from the initial, because initially it had a velocity of 16, and now it's what? 40. So it has changed from 16 to 40, so it has increased. Please do you get it? So their increase will be their difference, but here it will be squared, as I explained in the video earlier. So we are giving our mass to be 1600 kilograms. You can be given the mass to be in grams, kilograms, different units, but you have to convert, make sure it's in kilograms. Maybe in another video you are going to talk about how to convert the unit, how to convert one unit to another. So here we have 1600 kilograms, and we have our initial. So normally if you hear it increases from this to this, so the one it increases from will be your initial, because that's where it started. Initial means where it started from, and 2 will be your final, because that's where it ended. So you just fix in your values, half multiplying 1600 into bracket our final, which is 40 squared, minus our initial, which is 16 squared, I think we are going to get an answer like this. Yeah, I think so. So let's solve one last question. Good. A stone of mass 2000 kilograms moves from a roof to hit the floor, which is 5 meters away. Find the velocity of the stone just before it hits the ground. Take G to be 9.8 meters per second square. So we have this question. To try and pause the video and solve it, we are solving it together. Okay, so we have here, you see the question stated something over here. Okay, why is it? Okay, it says just before it hits the ground. So just before it hits the ground, so that means what? Our kinetic energy is equal to our potential energy. So just before it hits the ground, so here and the question says you should find the velocity, but the, for you to find the velocity, since I said kinetic energy is equal to potential energy, our kinetic energy, which is half mv squared, potential energy, which is mgh. If here you can see m is common, we can cancel m out, which will be remained with our v squared over 2, or half v squared. So we have this, that means we can cross multiply, and let me demonstrate over here. So it will be left with v squared over 2 is equal to gh. Good. So we can cross multiply and turn this one here. It's going to be v squared is equal to our 2gh. Good. And we can square root both sides, and this square will cancel the square. So that's how we got the formula. This is going to be v is equal to root of 2 multiplying gravity times height. That's how we got this formula. So kinetic energy is equal to potential energy. So we should find the velocity. So we just plot in the values. We're given our our gravity to be 9.81 meters per second square. We're given our height, or the distance from the floor, to be 5 meters per second. Just put it in 2 multiplying your gravity times height. But here someone might want to use this. You see, there are two ways of doing this. Someone might want to use this and find the, what do you call it, and find the mass, and after I come and plot it in this, because potential energy is equal to kinetic energy, then come and use to find the velocity. But it's a long distance, so long method, sorry. So we can use this formula and just substitute away. So in most questions, a data will be given which is not valuable. So if you use this method, the 2000 kilograms will just be a waste. But here you can try to use the other method, but it will still be the same. But to have a very fast approach, I think this will work. So I think you are going to get something like 9.9 meters per second. I think so. Okay, so I think this is the end of the video. I hope you've understand what you've said so far. So please, we'll be talking about power in our next video. So make sure you subscribe, you like, and you comment your opinions and the topic you want us to do next, the topic you don't understand. So this is FC Star Creation Tech and Technologies. See you on the next video. Don't forget to subscribe to get a notification when the next video is released. Bye.